Alright, so we're going to go over distributive property here. And with this question, our goal will be to isolate for x. So we're essentially going to try to solve for what x is. Before we do any of that, we have to work with distributive property. And what that is when we have a number outside of a set of brackets. Okay? And what that really means is multiplication. They don't write it in, but anytime a number is beside a set of brackets, it means you need to multiply. And when you multiply it, you have to multiply by each term inside. Okay? In this case, there's only 2 on the left side of the equals sign. And then on the right side, same idea, there's 2 terms. Okay? If you had a question that had like 3 or 4 terms, you'd have to do it to every single term inside. That's what distributive is. You're distributing it to every single number. Okay? So we're going to work on the left side of the equation to start. Okay? So I'll call my LS, and we'll do this in red to start. So we have a third, and we have to multiply it by x. So if I multiply 1/3 times x, do you guys know what that would multiply to?
No. Should we change the fraction to a number?
We're going to leave it as fractions, actually. Okay? So think about it. What number is technically in front of that x?
1.
1. Technically, there's a number 1 there. And when we multiply, we want to multiply, this is called the coefficient, the term in front of the variable. Okay? So we multiply 1/3 times 1. What's any number times 1? Do we know? Like say I did 5 times 1. What will that equal?
The number that you times it by.
Exactly. It's going to multiply the number that I times it by. So if I multiply by 1/3 times 1, what should it equal?
1/3.
1/3. That's it. So we're going to write it like that. We're going to write it as 1/3, and then technically that x has to accompany it. Okay? So that's 1/3 times x is equal to 1/3 x. Okay? Now in the second part here, we need to distribute this. 1/3 times 6. So we have to know our fraction rules when doing this. So I'm going to do this on the side as a side calculation. Okay? So 1/3 times 6. And when we multiply fractions, we want to make everything a fraction. So how can I make the number 6 a fraction?
Make the denominator 1.
Yeah, we can make the denominator 1. And do you guys, any of you remember the rules for multiplying fractions, what you have to do?
Nope.
Don't you just multiply the denominator and the numerator?
Yeah, we go denominators by each other and numerators by each other. So 1 times 6 is 6. 3 times 1 is 3. Okay, that's all right. So we have 6 over 3. So it's positive 6 over 3. Now, can I simplify that?
Yes.
What is 6 over 3, or 6 divided by 3? What does that actually equal?
3 over
2.
1.
Yeah.
What?
You could write it as 2 over 1.
Sorry, I
Or
thought
the
we were
number.
simplifying the fraction.
2. That's all right. Okay, so we did the left side. Okay, slow it down. Hold on.
Wait, what did we just do?
Okay, so we've done that part. The next thing we're going to do is we're going to deal with the right side of the equation. So we'll do this in blue. I'll call it the right side. Okay? Oops, I didn't write that. Right side. Okay, so same idea, but this time this fraction is a little more difficult to work with. Okay, so we'll have to know our fraction rules definitely to work with this. We have 3 over 2 times 4x and 3 over 2 times -2. So let's deal with the first part. Okay? Again, when we're multiplying fractions, okay, times a coefficient, we got to remember our fraction rule. So 3 over 2, and how do we turn 4?
4 over 1.
Yeah, that's right. That's better. Times 4, and we make 4 a whole number by writing it over 1. Okay. So same rules as above. We do 3 times 4, which will give us 12, and 2 times 1, which will give us 2. Anyone know what 12 over 2 is going to be?
6.
That's right, 6. So I can just rewrite that as 6. Okay, and I'm going to write equals 6 here. So now I have 6, okay, and that's our 3 over 2 times 4. What else do I have to write with it?
X.
Yeah, because that x was already there. So essentially what we just figured out was 3 over 2 times 4 is equal to 6. The second part of distributive property is we have to do it to the second number. So again, 3 over 2 times, and technically this is -2. How do I make -2 a whole number?
Put it over 1.
Yeah, it's the exact same thing as all the other ones. So we put it over 1.
I was going to say, isn't that a whole number on its own?
Oh, sorry, it is a whole number. I said that wrong. I said I want you to make it a fraction. Sorry. So still same rules. 3 times -2 is -6, and 2 times 1 is 2. And you can always use your calculator for this stuff. And negative 6 divided by 2 is going to give us actually negative 3. Okay. So when I multiplied this fraction by this whole number, we got negative 3. Okay. So that's the distributive property part of this question. Distributive property is always taking the number on the outside and bringing it in. The second part, though, is because technically I can solve for x. That's going to be my goal here. I'm going to try to solve for x. So let's scroll down this page a little. I'm going to rewrite everything in black so it's a little easier to look at. 1/3 x plus 2 equals 6x minus 3. Okay, so we have to collect our like terms here. So I'm going to move everything that has a variable, and that's going to be this term and this term. I'm going to move them all to one side, and all the constants, those are just whole numbers, to the other side. So these two terms, what I'm going to do is I'm going to bring 6x over. When I bring 6x to the other side of the equal sign, because it was positive here, what will become on the other side?
Negative 6x.
Right. Perfect. And then we have 2 and negative 3. I'm going to move the 2 to the other side. When I move this positive 2 to the other side, what will it become?
Negative 2.
Okay, so I'll put these in red again. 1/3 x, that stays the same. And we're moving 6x over, so that becomes minus 6x is equal to, and if this step was confusing, we'll go over it again. I kind of did it 2 moves in one here. We keep the negative 3 on the right, and when I bring the 2 over, it becomes negative 2. So now we have our like terms. I'm going to collect the right side first. So negative 3 minus 2 actually gives us negative 5. This is a lot harder to work with because we have a fraction and a whole number. Okay, so I'm going to do that in a whole nother step here. In order to combine these, we got to make them both fractions that have the same denominator. So I'm going to do that on the side again. Think of it like these coefficients is a third subtract 6. So in order to subtract fractions, I have to get a common denominator. So the very first step is to make this a fraction, which we put over 1. We already know how to do that. But I need to have a common denominator. So I need to turn this 1 into what number in order for it to be common?
3.
3. So in order to do that, I got to multiply the top and the bottom of the fraction by 3. So when we do that, we'll have 1/3. Okay? And we keep that negative there. 6 times 3 is going to give us our 18. And 1 times 3 will give us 3. When we subtract fractions, we keep the denominator the same. And then we just subtract the numerator. I almost forgot what that word was. 1 subtract 18 will give us negative
17.
Negative 17. Very good.
Yes.
So we got negative 17 over 3x, okay, which is really odd to look at, is equal to negative 5. Okay. The goal here is to get x by itself. So this can be really hard to look at right now. I'm going to show you in 2 steps how to get x by itself. Okay? I want you to think of it. If I were to multiply this, I could technically rewrite it as negative 17x over 3. Okay? And this might be easier for isolating if we write it that way. It's the exact same as above. I haven't changed anything. I just put the x on top. Okay? Is equal to 5. So, because it's all divided by 3, if I wanted to move this 3 to the other side of the equation, because this is divided by, what operation would we use on the right?
Times?
Yeah, we use the opposite. So we'd multiply by 3. Okay? So when we do that, negative 5 times 3 will give us negative 15. And on this side, the 3 is kind of gone now. So now we're just left with negative 17 over x. Now the goal is to still get x by itself. Okay? Because this is technically multiplication, to move negative 17 over, what operation would we use?
Divide.
Divide. Very good. So it becomes negative 17 over there. So this 17 drops off, and we have x is equal to negative 15 over negative 17. So I have 2 negatives. We've done a whole bunch of rules in this one. This is amazing. A negative divided by a negative. Anyone know what that's going to give us as an answer?
Positive.
Positive. Now I could write this as a decimal. It could be some decimal. Right? We could take a calculator out. Do I have one here? Yeah, I do. You can use one here. 15 divide 17. Get this huge long decimal, 0.882, whatever it is. Say approximately 0.882, and it kind of goes on. Or you can leave it as a fraction. It completely depends on how your teacher wants you to write it, okay? So let's kind of recap here, because we did a lot of stuff. We went through pretty much every fraction rule. Okay, we did distributive property to start, where you distribute the numbers into the brackets. We isolated a variable, and we moved things left and right on an equation. There was a lot of concepts in that one. And let me stop.
So is that like an